Bismillahirrahmanirrahim. We continue our discussion in software engineering. Was requirements analysis concepts and principles. We carry on our discussion within the topic and discuss further more concepts related to requirement analysis in today's discussion. What is requirement analysis? And we defined it as an activity to be performed by the system analyst or the software engineer to have a better understanding of the customer in order to develop a high quality software. We discussed the benefits or the advantages of performing requirement analysis task, and we had seen that even if someone does not like to perform the requirement analysis activity, so his efforts to develop a good quality software may go in vain. You need to properly understand the problem, only then you start developing the software. So this will not waste the time, not waste the efforts of the developer, also the customer will be happy. The main intention of designing or main intention to perform this step is to have or to define the data that is to be operated by your software, the functional requirements of the customer, what functions are to be performed by the software, and what will be the behavior of the software to different events, both the external events and the internal events. So these are three basic outputs to requirements analysis phase. We discussed in previous lecture that software requirement specification has further five subdomains. In first subdomain or first substep is known as problem recognition, in which we try to answer all words. We need to have proper understanding of the problem that customer is facing and for which which customer wants a software solution. Then we have to perform a proper evaluation of those requirements. Evaluation of the current working environment of the customer is then performed, and then a solution, maybe one, maybe more than one, are then synthesized. In third substep is to develop or design a model for the working software, how the software will work. That is generally a paper work. A model is designed on paper. Different functions are identified, the major functions, as sub-functions keep on refining with the passage of time. So major functions, their interactions, the data structure, those functions will operate on are highlighted as models, and on the basis of that model, then the software requirement specification report is generated, which is generally known as a proposal, and that SRS is then reviewed by both the customer and the developer. These were the points we had discussed in previous lecture. Let's proceed with today's topic of discussion. In today's discussion, we'll discuss the requirements elicitation process. Elicitation is actually the collection process, how we need to dig out the requirements from customer, how we need to collect, how we can gather the requirements from the customer. So different techniques are there to collect the requirements. We are going to discuss those different techniques in detail in today's discussion. The most commonly used requirements elicitation techniques will be discussed in today's discussion. But before the requirements can be analyzed, modeled, or specified in shape of a requirement specification document, the requirements need to be gathered or collected through some elicitation process. Customer has a problem that they have generally very attracted towards computer-based solutions. A developer responds to the customer request for help in order to guide them how the software will be the solution to their problems. Now, during that phase, when customer wants to have a software solution, he then contacts the developer. So from there, the communication begins. The most common requirements elicitation technique is to conduct a meeting or interview. So this is the first phase or the first step within the requirements elicitation process, that you initiate the process through communication. The customer will approach you, the developers. The customer will approach the developers and the communication process begins. Here, the meetings get started or the interviews of the customer gets started. The first meeting between the software engineer, who is the analyst here, and the customer can be likened to the awkwardness of the first date between two individuals or two strangers. Customers are not that open in their first meeting. They may not be able to properly define their requirements. Neither of the two persons know what to say or ask, as it is their first meeting. Both are worried that what they do say will be misinterpreted. Generally, the language problem may arise. Both the parties are thinking about where it may lead. Both want to get the things over early. But at the same time, both the parties want this meeting or interview session to be successful. Now, whatever is the case, if the customer is not able to properly communicate, if the customer is shy, if the customer has any communication problems, still the communication requires to be initiated. Only then the process of requirements elicitation will begin. So during first meeting or during first interview, generally the analyst is advised to ask context-free questions so that customers start feeling to ease down. Context-free questions is a set of questions that will lead to the basic understanding of the problem. The people who want the solution, the nature of the solution that is required by the customer, and the effectiveness of the first encounter will be then established if the breaking of ice happens. So the first set of context-free questions focuses mainly the customer, the overall goals, and the benefits. For example, the analyst may ask, who is behind the request for this software? Who will use the software? Who will be the economic benefit of the software? Is there another source for the solution that you require? That means if some other more appropriate person is there with whom the analyst must communicate to get proper information. So these questions help to identify all the stakeholders who will have interest in the software that is going to be built. In addition, the questions identify the measurable benefit of a successful implementation of the software and the possible alternative solutions other than the software solutions are then highlighted. The next set of questions, or the next meeting probably, then enables the analyst to gain a better understanding of the problem and the customer to voice his or her perceptions about the solution. For example, the questions in the next meeting or the next set of questions may be, how would you characterize good output that would be generated by the software? So you now need to highlight the input that your customer wants to give to the software and the output that he or she desires. So the good output is then characterized. This would be the next set of questions. What problem or problems will this software address? Can you show me the environment in which the solution will be used? So these are this next set of questions. And also, will special performance issues or constraints affect the way solution is approached? So what constraints the customer would like the software to meet? So these are then questions that are more elaborative and want to have more insight into the problem that the customer is facing. Now within the third meeting or the final set of questions then may focus on the effectiveness of the meeting. For example, the analyst may ask, are you the right person to answer these questions? In order to verify if proper information has been generated by the specific customer or the information source is some other person. Are the answers being provided by the customer can be considered as official? Are the questions relevant to the problem that you have? Am I asking too many questions? Can anyone else provide more detailed or additional information? So these are then the third level set of questions or the questions that can be asked in subsequent meetings in order to highlight the effectiveness of meeting. So by the third and the ongoing meetings, the customer will be quite comfortable with the analyst. He or she will provide more details about the problem, about the working environment they are working in, about the people who would use the software, and about the specifications that they want out of the software. So these questions and many other that analysts want to ask will help to break the ice and initiate the communication process, which is essential to have a successful analysis. Now that the process has been initiated, the next step is to have the facilitated application specification techniques, which we generally abbreviate as FAST. Facilitated application specification techniques, FAST. Too often, customers and software engineers have an unconscious us and them mindset. Rather than working as a team to identify and refine the requirements, every individual within the communication process defines their own territory and communicates through a series of memos, formal documents, and question-answer sessions. History has shown that this sort of approach doesn't work very well. Misunderstandings arise through this question and answering session. Improper information are generally collected and proper informations are commonly omitted, and a successful working relationship is hardly established. It is with these problems in mind that a number of independent investigators have developed a team-oriented approach to requirements gathering that is applied during the early stages of the requirement analysis and specification. And this team-oriented approach is known as the facilitated application specification techniques. Earlier, the meeting was face-to-face, individual to individual basis. One customer, one analyst. Now a team-oriented approach needs to be established in order to have more information to be generated by the analysts. This approach encourages the creation of a joint team of customers and developers who work together to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements. So the FAST has been used predominantly by the information systems community, but the technique offers potential for improved communication in applications of all types. So this technique, team-oriented approach for requirements collection, can be used in any sort of software project. Many different approaches to FAST has been proposed. Each makes use of a slightly different scenario, but all apply some variation on the following or on some basic guidelines. For example, what can be the basic guidelines? Generally, the team arranges a meeting on some neutral site, which is attended by both the team of developers and the customers. During that meeting, the rules are prepared and the level of participation of every individual is then established. Here the agenda is then prepared, or the agenda is suggested, which is quite formal to cover all the important points, but still informal enough to encourage the free flow of ideas, or we can call the brainstorming is encouraged during that meeting. Neutral site is selected only to have less pressure on the customers and also on the team of analysts. Then the facilitator, which can be some customer, which can be a developer or some other outsider, is generally assigned to have control on the meeting. Then the working mechanism is defined. For example, how the input on the meeting will be notified. Either can be in shape of worksheets, in shape of the electronic bulletin boards, in shape of the communication within the chat rooms or some virtual forums, whatever the sort of communication or the definition mechanism is to be used is then highlighted. The main goal of this all arrangement is to identify the problem, propose the elements of the solution, negotiate different approaches, and to specify a preliminary set of solution requirements in such an atmosphere which is quite conducive to reach to the desired objectives. The initial meetings between the developer and the customer generally occur, and basic questions and answers help to establish the scope of the problem and the overall perception of the solution which is being carried within the mind of customer. Out of these initial meetings, the developer and customer write a 1 or 2 pages product request. Then a meeting place, time and date for the first are then selected and the facilitator is chosen. The attendees from both the development side and the customer sides are invited to attend the meeting. The meeting is generally organized on some neutral venue. The product request is distributed to all the attendees of the meeting before the meeting date. This is sort of the agenda items that are being circulated among all the attendees, both the development side and the customer side. While reviewing the request in the days before the meeting, each first attendee is asked to make a list of objects that are part of the environment that surrounds the system. Other objects that are to be produced by the system and the objects that are used by the system to perform the proper function. So every attendee is asked to write about the objects, the data objects that are to be used by the requested software, the functions those objects need to perform, and the outputs being generated by different functions. This is again the sort of a brainstorming activity. In addition, every attendee is asked to make another set of services that manipulate or interact with the objects, such as different processes or different other functions which will be then required later on to be used by the objects. Finally, the list of constraints, for example, how much should be the cost, what should be the size of the software, the business rules, etc., and the performance criteria, for example, the speed of the software, the accuracy rate, these need to be developed by every individual attendee. The attendees are then informed that the lists are not expected to be exhaustive, but are expected to reflect every individual's perception about the system. So whatever comes in their mind about the output, about the software, that is to be written down as notes, so that those notes will be then discussed in the meeting. In reality, considerably more information would be provided at this stage. But even with additional information, the ambiguity would be present, omissions would likely exist, and errors may occur. For now, the proceeding or the product description at least will be highlighted. As the first meeting starts, the first topic of discussion is the need and justification for the new product. So the first topic that will be then discussed when the first meeting begins is why the product is required. So different attendees present from the customer side needs to justify their need to have a software solution. So everyone should agree that the product is justified. Everyone everyone attending the FAST meeting must agree that software must be the solution to the problem. Once agreement has been established on the software solution, then every participant presents his or her list for discussion, the functions, the objects that they have highlighted. The list can be pinned on the walls of the room using large sheets of paper, stuck to the walls using adhesive backed sheets, or written on some wall boards. Alternatively, the lists may be posted on the electronic bulletin boards or within the chat room environment for the review before the meeting, so that every individual attendee can review the points highlighted by every other individual attendee. So ideally, every list entry should be capable of being manipulated independently so that the list can be then combined. Entries can be deleted which are not agreed upon by all the attendees, and some more additions are then made in order to form a one common list. After individual lists are presented, a combined list is then created by the group. The combined list eliminates the redundant entries, adds any new ideas that come up during the discussion, but does not delete anything. After combined lists for all the topics have been created, discussion then goes on. During the discussion, that combined list then gets shortened or maybe lengthened or reworded to properly reflect the product or the system that is going to be developed. The objective is to develop a consensus list in each topic area. For example, what are the objects to be used within the system? What are the services to be provided by the system? What are the constraints that need to be met by the system? And what should be the performance level of the system? That list is then set aside for later action. So this is the FAST technique, in which a group-oriented meetings, more properly organized meetings are arranged. A group from developer side and a group from the customer sides jointly get together at some neutral point to have a meeting that can be physical meeting or some virtual meeting on the problem and the solution, and different components of solutions are then highlighted, which are written down in shape of a common list. The next step within the requirements elicitation process is the quality function deployment. QFD, or quality function deployment, is a quality management technique that translates the needs of customer into technical requirements. The needs of customer into the technical requirements for the software. Quality function requirement concentrates on maximizing customer satisfaction from the software engineering process. In order to achieve this, quality function deployment mainly emphasizes an understanding of what is mainly or what is basically valuable to the customer, and then deploys those values throughout the software engineering process. So here in this quality function deployment, generally the requirements of the customers are categorized in different categories. What is more valuable to the customer? Those requirements are placed at the top, and what is least valuable to the customer are then gets to the bottom. So quality function deployment categorizes the requirements in three categories. One are the normal requirements. What are the normal requirements? The objectives and goals that are stated for a product or system during the meeting with the customer are the normal requirements. Those requirements which are being explicitly told by the customer to the developer are the normal requirements. If these requirements are present, the customer is satisfied with their software. For example, the normal requirements might be requested type of some graphical displays if customer wants some special or some specific sort of graphical displays of their softwares, the specific functions of the software that are requested by the customer, and the defined level of performance if your software is fulfilling these requirements. So these requirements are known as the normal requirements. Normal requirements are those requirements which must be present in your software. If they are not present, your customer is not happy. So these are the explicitly stated requirements of the customer that should be incorporated in your system. The next category of requirements are the expected requirements. These requirements are implicit. Implicit means those requirements which are not stated by the customer. So these are implicit to the product or system and may be so fundamental that the customer do not explicitly state them. That means some requirements are understood to be present in the system, so generally they are not properly stated by the customer. They are understood that they must be the part of your developed solution. The absence of these requirements will be a cause for significant dissatisfaction. For example, expected is that there must be a graphical interface to the software. If you do not provide the graphical interface, that has not been demanded, but it is expected that that must be, should have been, must be present in this developed software. So if you do not provide this graphical interface, your customer is not satisfied with your work. For example, other examples of expected requirements are the ease of software interaction, the level of difficulty, how easy it is or how usable your software is, how easy it is to use the software. This is something which is generally not told by the customer, but they expect the use or the interaction level with the software must be easy. The overall operational correctness and reliability of the software and the ease of software installation, these are some of the requirements which are generally not told as they are implicit to the product. The last set of requirements are the exciting requirements. These features go beyond the customer's expectations and prove to be very satisfying, very happy when present. So these are excitement. If you want to give extra excitement to your customer, so these features are then added, which are not either requested by the customer or not even expected by the customer. These are some extra flavors which you add to the software in order to make them more excited about your work, to gain their attention, so they may contact you again for their next project. So these are the exciting requirements which are optional. If you want to add them in order to excite or to get attention of the customer, you can have them. So, for example, word processing software is requested with standard features. The delivered product contains a number of page layout capabilities that are quite pleasing and unexpected. So, the formatting, different sort of formatting provided within the Word document, word producing processing software. So if you provide extra editing features to the word processing software, the customer gets excited. So in quality function deployment, we generally categorize what is being more valuable to the customer. What is more valuable is generally either implicitly stated or implicitly embedded within the system or explicitly told by the customer. So those are important requirements that should be present in your system or software. For example, the normal requirements and the expected requirements. If you remove these two requirements from the software, your customer is not satisfied. While excitement or exciting requirements are the requirements which are a bonus to the customer in order to gain their attention. The last set of activity within requirements elicitation process is the use cases. As requirements are collected as part of the formal meetings, fast or quality function deployment techniques, the software engineer or the analyst can now create a set of scenarios that identify a thread of use for the system that is going to be constructed. The scenarios are often known as use cases that provide a description of how the system will be used and who will use the system. The actors and the functions of the system are defined. To create a use case, the analyst must first identify different type of people or devices who would use the product or software. Those actors actually represent the roles that people play as the system operates. An actor is anything that communicates with the system. So that can be some device, that can be some machine, or that can be a human. And that is external to the system itself, such as the human is external to the software. It is important to note that the actor and the user are not the same thing. A typical user may play a number of different roles when he is using a system, whereas an actor represents a class of external entities, such as people. They play just one role. For example, a machine operator is a user who interacts with the control computer for a manufacturing unit that contains a number of robots and numerically controlled machines. After careful review of requirements, the software for the control computer requires 4 different modes or roles for interaction, such as programming mode or the programming role, test mode, test role, monitoring mode, and the troubleshooting mode. Therefore, 4 actors can be defined: the programmer, tester, monitor, and the troubleshooter. In some cases, the machine operator can play all of these roles, while in others, different people may play these different roles independently. Since the requirement elicitation is an evolutionary activity, so not all the actors are identified during the first interaction with the customer. It is possible to identify the primary actors during the first meeting and secondary actors as the more you learn about the system. Primary actors interact to achieve required system function and derive the intended benefits from the system. They are the people who work directly and frequently with the software, while the secondary actors support the system so that primary actors can do their work more properly. So once the actors are identified, then use cases are developed. The use case describes the manner in which an actor actually interacts with the system. For example, which actor interacts with which functionality of the software. So before you design the use cases, you need to have answers to some of the questions, such as what main tasks or functions are to be performed by different actors? What system information will the actor acquire, produce, or change? Will the actor have to inform the system about the changes in the external environment? What information does the actor desire from the system? Does the actor wish to be informed about the unexpected changes? So these are some of the questions that you need to answer before designing your use cases. In general, a use case is simply a written narrative, that can be a written narrative, or that can be in sort of a diagram showing functions and actors who act upon those functions. So that can be a written narrative that describes the role of an actor as interaction with the system, or the way he would interact with the system. What functions will be accessible to specific actor are highlighted under the role of that actor. That is all for now. In today's discussion, we started a new chapter, that is software requirement analysis concepts and principles. And we tried to have an understanding with the term analysis. We defined requirements analysis. What is requirements analysis? It is actually the process of understanding the specific requirements that must be achieved in order to build a high quality software. The requirements are placed by the customer, but generally the requirements are quite vague, and the output or the solution or the software which is in the mind of the customer is quite vague. So the task of this phase is actually to refine the requirements, to dig out the structure of the software which is in the mind of customer on paper. So to have a better understanding what actually customer wants. So this is the activity being performed by the software engineer. It is very important phase. Unless and until you do not understand the problem, you are not able to build a proper solution. You may be good in developing softwares, but if you skip the requirements, if you skip to understand what customer wants, your skills of developing high quality software are of no use. So this is a very important step. You need to understand the requirements properly. Otherwise, your time will go waste, your efforts will go waste, you will get frustrated, and the customer may get unsatisfied, unhappy from your efforts. So within this step, we generally define three different elements. We define the data that is to be operated by your software, the functional requirements, what the functions are to be provided by the software to the customer, and the behavior of the software is defined in this phase. What is the response being generated by your software in response to the external and internal events? For example, if the software or if the operating system is changed, you have developed the software for one type of operating system, and now the working operating system of the client's environment has been changed. So what will be the behavior of your software? Will it be portable on some other platform or not? So these three components are then highlighted within requirements analysis phase. In today's discussion, we discussed 5 different sub-areas of software requirement analysis, which are the problem recognition phase, in which we try to answer all words. We try to understand the problem. We try to recognize either it is a problem or not. Generally, customer think of a problem may not be a problem actually. So problem recognition is the first sub-step, and then we evaluate the current working atmosphere of the customer in order to properly understand the problem and synthesize a solution. The solution can be a software solution or some alternative solution can be designed. Then after we have understood that software must be the solution for the customer problem, then we develop a model. The model can be a working paper model. We draw a diagram on paper to define different functions that are to be provided within the software, to define the interconnection of different functions, the data flow, the control flow on paper. After model has been designed, then the specification, requirement specification, is then written down in shape of a document, and at the end, the last phase is that software requirement specification or the proposal is then reviewed by both the customer and the developer. So these are the topics that we have discussed in today's discussion. We'll carry on our discussion on software requirements analysis concepts and principles in the coming lecture. That is all for now. I thank you all.